Hello everybody, I'm Mark.
And I'm Margie. And we're the Flip Flop Flyers.
Thanks for joining us here at the hangar at Flip Flop Flyer headquarters at the North Perry Airport in Hollywood, Florida. What follows now is our annual inspection video. It's again a little bit longer format because we're really diving into the details of how we maintain this aircraft, and you get to see all the behind the curtain systems that's hidden behind all the panels and everything. So we really do hope you enjoy this. We did take a little bit longer to get the annual completed this year. Usually takes a day, but this time it was a 2-day affair for the actual work because we found a fuel distribution block that was cracked and leaking fuel.
What's the matter?
So we had to procure that part and get our wonderful mechanic Shane back down here to complete that bit of the work. Along with that, we did do some upgrades to the aircraft. We found some loose rivets on the turtle deck, so we drilled those out, replaced those. And we also changed some fittings on the brake calipers from a slip fit to a compression fitting, and the same in the cockpit. We found a leaking brake line, so we repaired that and put a new compression fitting in there as well.
What that means for me is really long days. Like, he's gone in the morning to late at night, and he comes home, he smells like airplane sweat. He's not having an affair with a woman, he's having an affair with his plane, and I am fine with that because I know it's safety first, and he's taking care of everything so we can fly safely.
Absolutely. Anything that we ever find on the aircraft, we immediately make sure we repair it and address it. And what you also get to see is the work that we do on the rolling hardware, our landing gear, which is work that we do at every 50 hours, not just at the annual, because we're operating in a saltwater environment. It's very caustic, and these parts need to be pulled apart, inspected, cleaned, and re-lubed so they continue to run properly and don't create any problems for us or any safety issues for us as we go ahead. So thanks for joining us. Put any questions you have in the comments underneath after you're done watching, and we hope to see you back here soon for another video.
Take care.
Cheers, everybody. All right, everybody. Flip Flop Flyer headquarters here in North Perry Airport with Shane Morris. He's here to work out the annual on the aircraft today. Shane, tell us a little bit about yourself.
Hi, how you doing? My business is Shane's Air Repair. I have been actively participating in aviation maintenance since June of 1981. I've got several different backgrounds, if you will. I started off commercial aviation and from the bigger stuff, and now I'm dwindling down to the more personal general aviation and light sport aviation in general. So it's a nice change. You don't see the same thing every day. It's a pleasure to work with people like him.
And Shane's very, very knowledgeable about the Rotax engine as well, which is the primary reason, other than his personality and acumen, to have him come here and work on the Seamax, because he knows it intimately well. And it's nice to have that continuity of maintenance with somebody as you go along and build hours on the aircraft, so that you can recognize and head things off at the pass before they become a problem further on down
Absolutely.
the line.
Absolutely.
Thanks, Shane.
Thank you.
Let's get to work.
Pleasure. Let's do it.
Well, ran into issues. That's why you do your annual. Why you have somebody like Shane around to make sure everything's working proper. We found out we had a cracked fuel distribution block on the top of the motor when we were working with pressurizing the oil system after we changed the oil out. So we're kind of dead in the water now, waiting on part. While we're waiting on that stuff, we're going to go ahead and continue with a little bit more of the work on the aircraft right now. I'm going to swing the gear. You notice we've jacked it up now and on some jacks, and we're going to go ahead and make sure that the gear swings proper. All right. It's down. It's on. 3 in the green.
Wheels up on my side. Back down. I am going to grease that jack screw as well. All right, I got to adjust that nose one.
Switch again.
Yep. All right, so we got a green there. Let's give it a try again. All right, we're up. All right, let's try this again. Got it. Perfect.
There it is.
Yes, we are. So.
Sorry, everybody. Well, you trust me?
I do.
So, now that we have everything complete except for the repairs to the fuel system, we'll move forward with the preventative maintenance we do every 50 hours, including this annual, to the landing gear and rolling hardware.
I'm going to go ahead and pull the wheels off of the aircraft so that we can change the bearings in the wheels themselves. Do that every 50 hours because we're working in this caustic saltwater environment. We'll go through that in more detail after we get the wheel off the aircraft and show that to you. We're also going to pull the axle spindle out and the spindle bushing that is inside the armature of the landing gear as well. We'll clean them off, dress them up on the wheel, and reinstall them after we've relubricated them. Doing that again every 50 hours, as well as doing a little preventative maintenance to the brake caliper, goes a long way to keeping everything well lubricated, cleaned up, free of corrosion from the saltwater environment that we're operating in. So let's get started. Next up is to actually get the wheel off of the axle itself, and to do that we need to remove the cotter pin that's holding the castellated nut in place, and we'll pull that out with our pliers. So our castellated nut, go ahead and loosen that up. Here's the washer. Now, if the 4 pins are nice and released off of our brake disc, our wheel should come off fairly easily. Might need a little persuasion here. All right, we're gonna need to do a little center pull action on this to provide a little out pressure. The wheel is generally free at this point, but sometimes the brake disc pins in the brake posts, which are the nuts that go onto the bolts that hold the 2 halves of the wheel together, they can sometimes create a bit of a vacuum with the lube that's in there. So it's hard to pull the wheel outward and disengage those posts from the pins. I can see that the pins are all loose in there just fine, but I think we've just got some suction. So we'll just get a little center pull, provide some pressure as we turn, and that ought to do the trick for us. There, and you can see that the wheel is disengaging now. The gaps are opening on the pins here. We're fighting that vacuum pressure. And the wheel is now backing off nicely. Main thing is I don't want to pound on it or do anything like that. I want to provide easy, consistent pressure. It looks like we're nearly fully disengaged now. So we should be able to remove the wheel just by hand at this point. There we go. We have a bearing on either side of the wheel. And you'll notice that the bolts, there's 4 bolts that go through that hold the 2 halves of the wheel the aluminum wheel assembly together. On the back of them, they have these posts, which are hollow, and that's where the pins from the brake disc reside, and that helps transfer the torque or the stopping power of the brake disc when the caliper grabs to slowing down the wheel and providing your braking pressure. All right. And if you feel the bearings, and you can rotate the bearings by hand, you can feel this one's a little chunky, but movable. Yeah, that one's a little chunky, but movable as well. They're not seized up, but you know, after 50 hours of work in the salt water, numerous water landings and operations, washes, and relubes, they're ready to be changed. So those pins look pretty good as well. We'll get a look at that real quick. Yeah, they still have striations in them from manufacture where they were milled. It's really nice. We got good depth of the brake disc itself. Plenty of thickness there. You can see that the brake caliper itself is mounted on this flange that is attached to the gear spindle. When the caliper squeezes on the disc, it transfers the stopping power through these pins into those posts on the back of the tire and allows us to stop. So what we're going to do next is we're going to remove the caliper off of the flange so we can remove the brake disc out of there. The next operation is to remove these two bolts. Despite the constant washings and lubrication, you can see that there's some rust on these, and we'll dress them up and hit them with some anti-rust rust inhibitor and clean up the threads and all. You'll find some chalky corrosion, like you can see right here, on the back of the bolt sometimes. All right, now once the caliper's off, the disc just comes right out. I'll put that aside. We'll throw a little sandpaper on that as well. Once the caliper is here, I'm going to go ahead and loosen up these bolts as well and remove them. That's what you'd need to do if you were going to change your brake pads as well. So we'll just, you know, if you want to replace your pads, you want to make sure that you'll be able to get to them and remove the bolts. 3 of them, as you can see, 1, 2, and 3, they go through and actually hold the outer brake pad plate onto the caliper itself, and the other 2 act as sort of slide shafts for the inner brake pad to slide along and allow even clamping. 2-puck design. When the 5 bolts are out, there's your outer pad. We still got a lot of bite on that. And we have an inner pad that sits against the pucks inside. Wiggle it a little bit. There we go. Out she comes. You can see, again, a little bit of corrosion here. We'll be dressing these on the wheel. Both our pads, our pucks are free and moving fine. I'm going to take this, I'm going to move it into a position where it's out of the way. A little bit of safety wire. Keep this up and out of the way for us while we work. So we get it in a similar position to the way it sits when it's in operation. Now that that's done, we're going to go ahead and we're going to work on removing the axle spindle itself. The axle spindle goes into the armature, this horizontal piece of the armature right here. And there's a bolt in the back, a through bolt, that acts as a torque resistor. And between the stainless steel armature of the landing gear and the high carbon steel axle assembly is essentially an aluminum tube that's a bushing. Again, pulling this apart, this is where a lot of water can reside and seep in and cause problems. So we really want to focus on this area, making sure that it comes apart. And when we do this, unlike most of this hardware that I removed from the brakes, we will definitely replace that torque linkage to make sure that there's no threat of failure between inspection. So every 50 hours we're doing that. They're stainless steel standard hardware. I don't have the number, the size, bolt, and thread count, but it's readily available. Alrighty, same sort of thing. There we go. Again, you can see even though I've been lubing these, every time I go in the water, I get a little bit of rust and corrosion on the shoulder of the bolt. And the bolt size that I buy is quite a bit longer than what's required width-wise of the assembly, as you can see. But the reason I buy it this large is because I want the full shoulder rather than threads taking up any of the torsional load of the axle. And it's a nylon insert nut and a bolt, I'm sorry, a washer. All right, now that that through bolt's out, if you kept it lubed, you'll notice this axle just comes right out of the bushing. And you can see, like this was clear like this when I put it in there, you know, about 50 hours ago of operation. And this has been in and out of the water probably, I don't know, at least 20 or 30 times since then. And this is where the water gets in, and this is where it gets between and has that dissimilar metal corrosion between the carbon steel, the aluminum, and then the aluminum to the stainless steel. So this again, that'll get dressed and cleaned up. And then inside we have our aluminum bushing. This one looks a little tight on me now. I'm gonna have to provide a little persuasion. I'm not sure where I got this dowel from, but it comes in quite handy. It's just the right size to get the bushing out of the insert, out of the armature of the landing gear. There we go. Good. You see there's the hole for the through bolt to go through. It's got a bit of a angled, beveled surface here to accept the weld bump on the back of the flange on the axle itself. There you go. And again, there was a little bit of corrosion there, and you can see it on the surface here. There's still quite a bit of lubricant in here. But again, you can see how that corrosion happens between the aluminum and the stainless steel. So again, we'll dress this up and re-lube it, and we'll get a wire brush inside the armature as well to clean up any corrosion inside there. And now, for brevity's sake, we're going to skip over all the cleanup work we did with the wire wheels, wire brushes, Scotch-Brite, and good old elbow grease, and move right along to reassembly and change out of the wheel bearings. Enjoy. So essentially we're going to put it together in the reverse order that we started. So the bushing is going to go in first into the armature, but we're going to make sure that we lube it up real nice both inside the armature and on the outside and inside of the bushing. Just get a little our waterproof grease in here. And so again, we looked at these. We had a bearing on either side. So to pop those out, we just need to get a drift pin in and give it a few pops with the hammer, and we'll push it out of position. I'll pop up the back one there first. You want to make sure when you go through that you're hitting the bearing on the other side and not hitting the any part of the wheel assembly itself and doing any damage to that. So just go in at a shallow angle. We don't want to go in at a high angle like this because you'll be hitting between the bearings and doing some damage to your wheel itself. Catch the lip of that other bearing and boom, it's out. Popped out of the race, there it is right here. We'll be discarding that. And you notice you don't want to do any damage to that race by poking through. So the other side will do it as well. Then again, here's wood, I'm just coming up enough to catch the edge of that and give it a couple of pops and boom, it's out. And that bearing's out on that side. We're also going to go ahead and sacrifice this rag, clean out our races here. Before we put the bearings in the tire, in the wheel itself, we'll go ahead and prep these bearings. It's a very interesting little process, simple, but I wouldn't call it necessary, but it goes a long way to making your wheel bearings last until the next 50 hours. The bearings themselves have a little bit of grease in them when they come. They are a sealed bearing, but they're not tapered at all. An inner race, outer race, and it's got that blue seal on either side. And there is some grease inside there. That's great, but there's still a lot of voids in there that allows seawater to infiltrate if you are in the water. So what we're gonna do is pop those seals off and fill those spaces with our own grease, this waterproof grease. All right, so what we're gonna do is just on each of these, get a little pick inside there. Don't damage the seal and just pop it off. See, it's kind of got it's this rubberish plastic material wrapped around a flat metal ring. And we'll do that on both sides. We'll do it to both bearings. And the thing I want you to notice is how much of a void there is between the bearings inside here. You know, you can see how the internal race moves and rolls on the bearings. And there's just a lot of airspace there, despite there being grease. So we're going to be very prolific with the use of grease on these ourselves, and stuff them full. We're going to make a hearty mess out of this and take our grease, just got a nice bunch of it, slam it down into the area on top of the actual bearings themselves. Just squish that right in there. Clear out the center. Just use that material. Flip it over. Do the same. Force that into the races and into the voids in the race. And this helps prevent the infiltration of any salt water in. And we're just going to squeeze from both sides and work our way around and just make sure we squeeze that stuff all the way in between the bearings in there. And if it is all in between the bearings, we'll use a little bit more there that we push through and just cap it off. And having a little extra in there is no problem, because we want that as full as we possibly can have it before we put one of the caps back on. And we put that cap back on, just flick it down into place. You'll see some grease ooze out around the edges. That's fine, and we're probably going to see some grease having popped out the other side as well. Use that grease to just fill in the gaps. Make sure we're just totally full, no airspace in there at all for any water to get in, and then we'll put our other seal back on top, and we'll just press that into place. And you notice you can see the grease just coming out. We know we've got all the voids filled when that happens. Good. I'll wipe some of that off. Come on now. It's a little slippery because I got grease all over everything. And we're just going to use that on our other bearing. This is all clean. Let's put this bearing aside for now. Then we'll work on this one. Give it a quick wipe down. So that really makes a huge difference. When we do our nose wheel, we do the same thing to the bearings there. All right, now bring this down. Show you how we put the bearings back into the wheel. All right. So I do have a press, a hydraulic press, to help press these in, but it's not necessary as long as you have, like an impact wrench socket that's big enough. It's the right diameter for the bearings that you're using. So to do it, we'll just bring the tire over. All right. Again, take a quick swipe around the race where the bearing's gonna go. The bearing hole here. Real thin bit of grease to protect the surfaces and keep the surfaces from adhering to each other under any salt intrusion. We'll take one of the bearings and place it right inside the race, and you can basically get it most of the way in by hand. When it doesn't go in by hand, we can match the top here, and you're not hitting really hard, you're just tapping to make sure that all points around the edge of the bearing are pushed down into the wheel itself, and that you don't have any protrusion sticking out. All right, so we got a good bearing in on that side. Now before we throw the other bearing in on the other side, we're gonna fill that void space in the tire between the back sides of the bearings with the grease, so that, again, we're eliminating airspace where water can infiltrate and create corrosive problems. Again, finger method works really good. And I know you're going to put an axle through here and you're going to lose some of this, but what we want to do is completely fill that space behind that other bearing. Now we can put our other bearing in. And then again, you just want to seat it the rest of the way, all the way around. You can hear a change in the tapping when it bottoms out and is fully within its seated position there, which it is right now. And now you'll notice you've got zero light coming through that hole there. That entire void between both those bearings are completely sealed. So it's time now to put the wheel back on the axle. This is where you're going to have to catch some grease coming out of the bearing opening. So be ready for it. As we put the wheel back on, I'm going to make sure that the 4 pins here go into the 4 open posts on the back of the nuts. And before we slide it all the way on, I'm just going to dab, just between my fingers, a little bit of grease to put on these posts. It goes a long way to keeping them moving properly in and out of those holes in there. I'm going to throw just a hair of grease on where the bearing is going to sit inside on the axle itself as well. This helps protect the axle and also make it easier for the bearings to slide in and on. Just move it on, and now you'll see the grease coming out in a plug here. Same shape and size as the axle. So we just push that through the void and got that nice fresh grease out. And we missed our posts. There we go. Now the posts are going in. There we go. Pins are in the posts. We're all the way in. We've cleaned up our hardware here. And we'll use some of the residual grease that's on here, and we'll just coat these pieces before we put them on. Then our castellated nut. Look at that, all right. And the idea is to tighten this castellated nut up tight and then back it off so that you can get pinned through between the castle points of the castellated nut. You don't want to over tighten and put too much pressure laterally on the bearings, because that will cause damage to the bearings. And now I can get a cotter pin through there. So this goes through from above, and then we bend the tangs. All right, so wheels back on, all nice and lubed together. One last thing we're going to do is just test the brakes. Now we just press on the brake, make sure that it grabs nicely on the wheel. And it does. She's ready to go. Last item, as you probably remember, is just getting our last 4 fasteners put in to hold our gear door in place. Perfect fit. And so that, everybody, is a landing gear disassembly, cleaning, lubing, and reassembly at each 50-hour inspection of the Seamax that avoids any negative consequences of operating in salt water. And this will be in tip-top shape and be the same exact thing 50 hours from now. Well, we hope you enjoyed that. Might seem a little tedious, but it's really not nearly as bad as it seems, and it really goes a long way to keeping this aircraft in like new condition. Next up is a quick recap of what we found at the annual that needed attention. I didn't get any video of us correcting the fuel leak situation, but I think you'll get an idea of what we were up against and what kind of work was needed.
Cheers. Okay, Mark here again, still at the hangar. We're finishing up the annual on the Seamax today. We got slowed down when we tried the first day because we came up with a couple of items that we needed to address, one of which was this little switch right here, which is a squat switch to give us a nose gear indication. If you look at the top of it, you can probably see that it was getting corroded from salt water leaking into it, and we discovered that it was the positioning of the lead lines for this that were touching a part of the airframe that, when the canopy was opened after we were in the water, allowed water to drip down the cable right into the top of the switch, and so it was causing problems. We got a new switch put in there now, working fine, good to go. Another item that we found was on the brakes. This fitting at the top here was leaking when I was working on it, so I decided to change it out from a slip fit connection to a compression connection. And when I bled it, I discovered that we had a tremendous amount of air in all our hydraulic lines that reside down in front of the pedals on either side of the aircraft. And it turns out it was this fitting here. I did change it out again from a slip fit to a compression fitting, but it was actually the supply line on the back of this T right here that was cracked at the top, and it was introducing air into the system, and it drove me rather insane for afternoon. But we're good now. All right, one last thing we got to address today. We discovered that there was a problem with the fuel distribution block on the top of the engine. I'll give you a shot of that right now. This block right here, you can see, takes pressurized fuel from the fuel pump up to this block at the bottom and essentially distributes it in two directions to the carburetors, one to the starboard side, one to the port side carburetor. And it also, through the front of the block, sends fuel pressure to the pressure sensor to give me fuel pressure readings. And this other line right here, which is normally attached underneath this nut right here, that is for our return line back to the fuel tank, because the fuel pump produces more pressure than can be used by the carburetor, so the additional fuel goes back to the fuel tank. This block here is cracked at the front where this fuel pressure sensor fitting is. So we were spewing gas, and of course that's a no-go item, so we made sure we get that taken care of. All right, back with you soon. Okay, last up is a more detailed view of the Seamax systems and installed equipment. We hope you enjoy. Okay then, now that we've got the airplane taken apart and you've seen how we work on the landing gear, I'll take you around the airplane a little bit here and show you the systems in a little bit more detail, what's behind the interior and bulkheads and instrument panel, so that you get a chance to see everything that's the Seamax is made of. Avionics, backside of it here, backside of the instrument panel. We have our Garmin, the GDL52. We have our comm radio right here and our transponder underneath. Backsides of all our engine instruments in this segment here. You can see, if you look in here a little bit closer, our brake reservoir is right here. Our pedals are right here. You can see all of the
hydraulic lines that connect the actuators for the brakes on the back side of the pedals, and they interconnect to the other side. We have a very similar arrangement here. We talked about the landing gear switch for the nose gear. That's right here, behind the armature here. These springs help put the landing gear and the nose gear in a over-center position, keep it there. And the other side of the back side of the instrument panel with our G5s, Era 760 in the center. Here we've got our main actuator for our elevators. You can see the elevator push rod, the aileron connections right here, and the aileron cables that go up into the ceiling. This here is our 1.6 gallon header tank that both fuel tanks drain into. This is our flap actuator motor here with the various switches illuminating the indicators at the various degree settings. And behind all that, if I can get in here, you can see right there, that is our jack screw for the landing gear, which articulates like this. Master switch on, and you can see in there the various components moving kind of a butterfly. Tracker takes both sides up the jack screw and brings the gear in, and go back to the down position. Again, jack screw in there, brings the arms down and moves the landing gear to a full down position. I have 3 in the green right there. Here's our flap indicators and the various indications of how many degrees of flaps we have based on where this piece moves in relation to the squat switches. Some sound insulation up top. The tongue sticking out above. You can see sky through over there. That's for where our inspection panels are on the upper part of the wing. All our antenna connections, the fuel gauge, sight glass, and fuel valves in each wing root. Our seatbelt attach points are on this main carry-through structure spar here, and there are 2 spots, 1 on each side, and our shoulder harness is attached there through the bulkhead. I've got the light down in our hole here, so you can actually see our sump pump and some of the control cables by the light there. That sump pump has an orange cap on it. You can see the tube that leads out, and that leads out to the wheel well right there. You can see the exit point. And that comes right out here in the aft end of the port side landing gear bay. Other openings allow us to see inside at our wiring, conduit, and our control rods that run to the aft end of the aircraft, and our antenna connection. The back end of the aircraft, the inspection panels are open to see our stabilator control arm here. Moving allows us to lubricate, inspect the parts. Same down here. the aft bulkhead, the turnbuckle there. Piece of hardware there that transmits the forward and aft movement of the tube here into vertical movement up the tail. Pretty straightforward design, easy access, no real issues there. Top of the wings, we have this access panel that allows us to look at our flap torque tube that is run by that electric motor. Torque tube arm comes down to this push rod, which then moves the flaps down into the deployed position. If you do look in the cockpit here, behind where the seats would be installed normally, you have your battery right here and our ELT right here. So that essentially sums up the overall systems in a little bit more detail for you in the Seamax. 14-volt electrical system that drives the flaps and landing gear. The hydraulic system that runs the braking system, as well as the mechanical portions of the flight controls that move all our control surfaces. Pretty simple airplane, well engineered, well put together, and does what it's supposed to do pretty consistently. Thanks for joining us. Appreciate your time. I'll see you here soon again. Cheers.
All right, everybody, thanks for watching. We appreciate you sticking around and checking out this video. We hope you learned something, and we hope you gain some more insight into the Seamax itself and operations in saltwater here in South Florida. Again, put your questions in the comments down below, and we'll do what we can to answer them all for you. In the meantime,
Remember, safety first.
yes,
That's what this is about. Take it seriously, guys.
absolutely. Thanks for watching. And
Cheers from the Flip Flop Flyers.
See you back here soon.